Let's say you need to do a data analysis and all of your data lives inside of AWS S3. You have to find the data inside of S3, create a Athena query engine on top of that so you can query the data, and then you have to refine that query in order to analyze the data properly. What if I told you that with this video, you would not have to do that again? In this video, I'm going to show you exactly how to do that by connecting AWS CLI to your AWS data lake. And then here's the real magic, as it has been in the case with my other videos, how to let Claude Code handle the heavy lifting of working with S3 and Amazon Athena for you. So the real power here isn't just running AWS commands from your terminal, but having Claude take care of searching in S3 and querying Athena for you. You describe what you want in plain English, and Claude figures out the right S3 paths, writes the Athena queries, and handles the execution. And your main job, QC the results. As has been the common theme of my videos when working with AI, that is your job to manage this. So this will be an extremely valuable and time-saving video for all of us who have worked in S3 and Athena with our data to place it, find it, and analyze it. And for all those prospective data professionals out there looking to get into the field, working with AWS is something that I know almost everyone in the field does. I've been working with data for over 9 years now, and for me currently, my team has multiple reporting jobs that produce CSV files that are saved to AWS. If we want to query that data with Athena, we need to navigate to where the data is placed within S3, and then we need to set up the structure within Athena if we haven't done it before to properly query it, which means we are spending time searching and navigating through interfaces all to configure this. But now with Claude, it can quickly interpret the information for where data is stored in our S3 buckets and then quickly set up the queries to Athena to give me the information that I need all on my laptop. Additionally, it can navigate to S3 and place files there where we need it to, when we need it to, and find them. So today, to show you the power of this integration, I will first show you how to install the AWS CLI and cover the prerequisites you will need in order to have it work. And then we will utilize that AWS CLI as if we are doing a real data analysis, placing data into S3 and then analyzing it using Athena, and compare that process to what we would have to do using the AWS console. Before we jump in, let me quickly define a few key terms you'll hear throughout this video. The first one, S3, one of our primary concepts we'll be covering is Amazon's cloud storage or data lake. Think of it as an infinitely expandable hard drive in the sky. And S3 is a data lake, which it is a storage approach where you dump all your raw data into folders and then you figure out how to use it later. And our second primary concept is Athena. It's a query service that lets you run SQL directly on files in S3. So you don't need to set up a database like you might need to with Redshift or Snowflake or Google BigQuery. And then that leads us into an external table, which is what allows Athena to work. And it's a table definition that points to files somewhere else. So like inside a folder structure or an S3 bucket, as we call it. So the data stays in S3 and Athena knows how to read it. And then lastly, that's important to note, is YAM or IAM, which is AWS's permission system. It controls who can do what with your cloud resources. And so this is really important for knowing the prerequisites that you need to have done in order to allow AWS CLI to work with Athena and S3, as we will do in this video. All right, so now let's get the AWS CLI set up. To show you all here, there are some prerequisites that we'll go through, and I'll show you how to configure the IAM credentials if you're the administrator of your account, or what IAM credentials you need from your DevOps team if they handle this for you. But first and foremost, you will need an AWS console, and these are actually free to sign up for. I'm using a free version right now for this demo, and it's very easy, zero cost to get started. But that said, here's the command line for the official installation from AWS. And then if you're curious, you can check out the specific S3 commands, the specific Athena commands that are available via the AWS CLI. But what we'll do here is instead of running this in our terminal, right, to install AWS, you need to run a terminal command. I'm going to show you all how I normally install new command line interfaces, like I've done with Snowflake, Jira, all the past videos. I showed you all the actual bash commands for my Mac that I ran. But instead, I'm just going to have Claude do this for me and say, hey, please install the AWS CLI, as this is a super seamless way that you don't even need to necessarily look up how to download and install these different command line interfaces, and you can just rather have Claude do it for you and verify it for you too. But I'll show you the verification. So let me run this command. We'll pause here and come back once it's installed. All right, so I already had the AWS CLI installed, but it upgraded my version here. And if I go into my terminal without Claude running in this area, I can just say AWS version, and then boom, verified that it is actually working and installed via Claude. And so now we need to actually run AWS configure to provide my access key, secret access key, default region, and output format. So let's do this together, and I will show you where you can get this information. In order to get the right information for the AWS configure command, you're going to need an access key ID, a secret access key, your default region name, and then default output format, which I'd recommend JSON in this case. So to go to IAM, you can click on this IAM button if you have it up, or just search it in the bar within your AWS console. Go to your dashboard and then click Users. And then here you can see I have already created my Kyle Chalmers CLI user. And within this, I already have an access key configured here in this blocked out area of my screen. And you can see here that I have it configured there, which it generates the key ID and then the secret access key in order to truly authenticate. And if I was going to go through this process from scratch, what I would do is I would go into create user, which you can find on that users page, and then go through demo. You can provide access to AWS Management Console. That's just if you want it to be able to actually log in, and then set permissions. And really the most important thing here is you need to, at minimum, have S3 read access and Athena query access. It might be better to give it more permissions on S3 to actually put data in there, but these are the permission policies which you can look up. If I look at my user and look at the permissions, you can see I have administrator access because I do other things with this user as well. And then S3 and Athena full access. So these are packages that you can assign to it. But if I just look up Athena, here we go, you can get into the specific policies that you want to provide to this user, review and create a true password, and then boom, you have your information needed to enter for AWS configure. And one more thing to note for this configuration, if you're working on this on your company account, you probably won't have access to this interface as a data person, but I would talk to the people who are in charge of your development operations org or DevOps, or somebody at your company who administers AWS, and they will likely be able to help you out with this. That said, switching over to our terminal again, you can see here I went through the AWS configure. I didn't need to do it since I'd already set up my credentials along with my region name and JSON. And so this will be all information you can find within your AWS console. And then to verify that this is working, I can say, hey, get my caller ID. And then up here, is information with my user ID, account, ARN. And I've blurred all of this out just for privacy purposes, but that's how you know that you have successfully set up the AWS CLI and you are good to go here. If you have multiple AWS accounts, say a development, a production, you can actually configure those using AWS configure and then setting a profile. So I could do production or dev and then go through the same process I just showed you to get credentials for both of those types of accounts. Also, for your configuration, with the results of Athena outputting into JSON as we put that in there for the configuration step, we'll want to make sure that we have this package called JQ installed, and I install it via brew. Additionally, you can get it from this download here for all the different machines that you might be on, but it's really important to have it there so it can understand the JSON data as it's outputted. One other thing I would like to note before getting into the actual analysis is that it's really important for this information to actually pursue beyond your current session with Claude, that it has access to the AWS CLI. So if I pull up my CLAUDE.md file here, which you can see below my face, but I have in my window here within cursor, you can see it has a section for available CLI tools that Claude has access to, and that every time I open this repo, it will know that it has access to those CLI tools. And so what I do after installing this AWS CLI is I want to make sure that it continues to know that it has access to this tool. And so I just write a quick prompt for Claude to, hey, make a bulleted note like you did with these other CLI tools and say that you have access to them. And we can see here that it just added those operations in here too. And so this is, again, very important to make it seamless, that you build up that context that, hey, Claude, you do have access to the CLI. With that, let's actually introduce our data analysis and go through some examples. So for this data analysis, so you all can follow along if you would like, I am utilizing this climate change data set here from this climatedata.imf.org website compiled by different publicly available climate research data sources. And as far as what this data actually looks like, we can see it here within my GitHub repository, or you can download it there. But basically, there's a country, and then the indicator and the unit of degrees Celsius, and it is of their surface temperature change since 1961, utilizing the baseline. I think it's an average of 1951 to 1980 as the baseline temperature. And so we can see here that this data set is very large horizontally wise. I think there's a few hundred countries that are within this. So now transitioning to the actual work with Claude, I have a prompt pre-written here, and you can see it as well in my README, along with some other information about the demo data set. But basically, I want to show that, hey, we can upload this data into S3, and then put it inside of a folder and then create the necessary Athena infrastructure to actually query it, write the queries, and then give me the results of the analysis. And so I have this portion to upload the data, this portion to create the location for the data inside of S3 or simple storage solution, and then actually perform the analysis where it may need to set up the Athena infrastructure to query the data, write the query to pivot the data set so the years become rows, because right now it's very horizontal, and ordered by the highest temperature change is ascending. So I can look at that data set and say, for these years, for these countries, these were the biggest changes that we saw. And then ultimately save those pivoted results to my final deliverables folder here. And then I want to query the Athena with find the 5 years with the largest mean temperature change for the United States and tell me the results. And I'm actually going to alter this prompt really quickly so that it writes out all the Athena queries as well so we can validate this. Okay, I just said, give me the queries for all of the Athena analysis in the final deliverables folder. So what we will do is we will click run, and then off we go with Claude. And actually, I'm going to do plan mode first, just because I want to make sure that it does this correctly first. So write me a plan. And then once it presents me with the final plan, then we will have it work. Okay, the plan has been created and I'm liking what I am seeing. It has a clear objective for what it needs to do, and then gives me the commands that it is going to run, and then what it's going to do to create the external table within Athena based upon this data, and then how it is going to pivot the queries as rows, and then it will ultimately save the pivoted results here. And this all looks good. If we need to make iterations on it, we can after it is complete. But what I'm going to do is say, yes, clear context, and then bypass permissions, which is a new feature that Claude has introduced to clear the context before running these plans. That way you can stay with the context that you need. So we'll let this run here for a little bit, and I will check back in once it has completed so we can review the results. And now this analysis is complete. Only about 5 minutes later, it went through the whole AWS section for S3, checking if there was a bucket, and then ultimately uploading the data and setting it up. And then it goes creating the Athena infrastructure to create the database, do the query execution, ensure itself that it all worked correctly, and then get the results from all the queries that it ran. And so we can see the queries that it ran up here as well in 1, 2, and 3, which looking at the pivoted data, here's our top 10 for the areas that saw the largest temperature change. I've actually never heard of the Svalbard Jan Mayen Islands. So that's really interesting that they're seeing a very high increase in temperature there due to climate change. And then if I look at the US data here, we can see all of it is fairly recent, apart from the early 2000s with 2004 there for the highest temperature change, with the most recent coming from 2022. And we can see that query here. Not exactly the ideal structure for a query, but I can work with Claude and Athena to potentially refine this approach and maybe use an unpivot function as opposed to a union all here. So I will iterate on that. But ultimately, this gives us exactly what we need, and all I had to do was prompt it without going into the AWS console. So I'll show you really quickly so you can get the comparison for what this process would be like if I had to go through the UI in order to complete this. Now, to briefly show what this process would have been like in the AWS console, if I go to my console here, click S3, I would have first had to create a bucket, which we can see is already created here for me by Claude, create a folder underneath that bucket, and then ultimately upload this CSV via this manual upload process. Now, if I go to Athena, after completing that manual upload process, then I would have had to come into Athena, and I'm going to go back to the home page here first, click Query Editor, and then set up these query settings. And you can see here that there's a query result location. So every time there's a new result, based upon the SQL that's entered into Athena, it writes out into that bucket location, which we saw in the first screen when we're looking at S3. And Claude did this all automatically for us, so we don't have to do any sort of configuration for this. And I can look at the climate demo database here, run this query, and then ultimately get the results validated below for the United States here. And if you notice, this query is different than the last one I showed. I went to Claude and said, hey, can you write a pivot query any more efficiently? It iterated a couple times and then ultimately landed on this unnest approach, which is a lot more efficient than 64 scans. So if you have to pivot your data inside of Amazon Athena, definitely use cross-join unnest with this approach. And that is how it would be done in the interface. So you can just see inside the command line with Claude Code how much more seamless this is for us to be able to get the results that we want, as opposed to having to switch back and forth between interfaces, manually download the results. All of it is within one Claude Code interface. Super easy for us to get and saves us a lot of time. And we have reached the end of this video. To recap, we installed the AWS CLI, making sure we have the right permissions in place, and then also connected it to S3 and Athena, and walked through a complete data analysis workflow, uploading data, querying it, and getting our results and output while using Claude in the driver's seat to do all of that work for us. And I hope you can really see the value case here, that using the CLI combined with Claude really allows you to get into S3, Athena so much quicker. So if this helps you work faster with those tools, please drop a like and subscribe. And I'm creating more content on AI-assisted data workflows, so please hit that bell if you want to see what's coming up next too. And I'd also like to take a moment to apologize for the sporadic releases of my videos. I'll be coming out with a little bit more fixed schedule here in the very near future. With the birth of my son, I'll say finding the time has been difficult, but I will get that sorted out as we adjust to this wonderful new life that we have. So thanks so much, and I will see you in the next video. Talk soon.